Welcome back to College Algebra. Today we're talking about solving equations with powers and roots. So last time we talked about solving linear equations, and today we're going to make that more interesting by adding powers of x and adding roots of x. The key idea, as we talked about last time, is to always solve these equations using inverse operations. And additionally, as we use those inverse operations, we always go from the outside in. That is, from the last operation that acted on x to the most recent. And we undo them one at a time using inverse operations. If you don't recall, an inverse operation is an operation that has the opposite effect on the problem than the operation that's given. So for example, if you're given addition, you use subtraction because addition and subtraction have opposite effects. Addition undoes subtraction and vice versa. Similarly, we saw that multiplication and division are inverse operations. Today, we're going to talk about powers and roots, and the reason why we put those together is because powers and roots are examples of inverse operations. If we want to undo a power, then we use the roots to do it, and if we want to undo a root, we use a power to do it. So what are some examples of this? Some examples of this are x squared, which has as its inverse operation the square root of x, or x cubed, which has as its inverse operation the cubed root of x. You'll notice we use the 3 on top of the radical sign to identify that it's a cube root, and we don't have anything there for an x. If you'd like to review a little bit on how to think about radicals or use your calculator to compute radicals, you might want to look for the link at the top, and it'll send you there. Let's start with a couple problems and see how this works. Our first problem is going to be the cube root of x is equal to 4. And what we have to do is look at this problem and ask, what is the inverse of the cube root of x? And you recall from the page that we just had, the inverse of the cube root is cubing. So if we want to undo this cubed root, just like in the past, when we wanted to undo addition, we use subtraction. To undo a cubed root, we cube. So we take this cubed root and we raise it all to the third power. Now always when we work with equations, you always have to have the same behavior on the right and the left so it doesn't change the value of the equation. And so we also have to cube the right side. Now what's left over when we take this cubed root and raise it to the third power? Well, what's left over is just x all by itself. And it should be just x by itself because we used the cube power specifically because it's the inverse of the cube root. And so these two undo each other, leaving just the x. We'll get into this in more detail when we talk about exponents and how exponents interact with x's. Now over here we have to say what is 4 cubed. Maybe you remember, but if you don't, let's just compute it down here by ourselves. So notice we could compute 4 times 4, which is 16, and then calculate that times 4, and notice 16 times 4 is 6 times 4 is 24, 4 times 2 is 4, 5, 6, and so 64 is what we get when you take 4 cubed. For those of you who like basketball, you'll notice 64 is the number of teams in the NCAA tournament. And when you do the NCAA tournament, there are 4 weekends, and each weekend has a group of 4 teams involved. So we had 4 times 4 times 4 was 4 cubed. If doesn't matter to you, then that's fine. Feel free to forget it. Okay, let's look at another example. The example this time is going to be x squared equals 4 divided by 25. And now, last time, in order to undo a root, we used a power. Now notice that we have a power. To undo the power, we're going to use a root. And since it's a square, which root do we need? We need a square root. And so we're going to square root both sides. So over here we get just x because the square root and the square undo each other. Students like to say cancel, and that's okay. It's not an incorrect word. I find undo is maybe a little bit more appropriate. And over here we have to say, what is the square root of this 4 divided by 25? Well, again, we could use our calculator, we could use some sort of device, but I think we can do this in our head by realizing that square roots work nicely with fractions. And that is that we just take the square root of the top and the square root of the bottom and put them together. And the square root of 4 is 2. and the square root of 25 is 5. And so for this solution, we get 2/5. Now what you'll notice on the two examples we've done so far is you notice that on this example, we had a power, and so we used a root to solve it. On this example, we had a root, and so we used a power to solve it. And so that's going to be our general principle. We're going to solve problems the exact same way as we solved them before, except whenever we come across powers or roots, we have to use the appropriate inverse operation to undo them. Let's do a couple examples that have a little bit more going on. Let's start with the example of the cube root of 2x plus 7 equals 12. Now again, we have to look at this and ask, and notice that we have a lot of things going on. We have a cubed root, we have a multiplication, and we have an addition, but we always need to ask ourselves, what was the outside thing? What did we do first? We have to work our way outside in. Now as I look through this problem, I would notice that if this x, the first thing that happened to it was multiplied by 2, because the x and the 2 are both inside the radical sign. And then once those two are computed, you took the cube root of the 2x, and then finally this plus 7 was the last thing to happen to the problem. So for me, since we're working outside in, the last thing to happen to the problem gets removed first. We're going to undo this 7 first. And remember from last time, we undo addition by just subtracting. And this gives us that the cube root of 2x is equal to, and now we take 12, subtract 7, and get 5 for our answer. And now we have two operations. We have the 2 and we have the cubed root. Which one do we undo first? Well, I'm going to undo the cubed root first because the 2 and the x are inside the cubed root, and so they happened first, and the cubed root is on the outside. So the cubed root is what we get rid of first. You'll recall from just moments ago, the inverse of a cubed root is a cube. So we'll cube that side and cube both sides. We always do everything to both sides to keep everything balanced. This cubed and this cubed root should undo each other, and we get 2x. Now what is 5 to the third power? Well, we could come over here and calculate it out and work it out. I would encourage you to do that if you don't remember. I happen to know it. The answer is 125. By the way, I think it's worthwhile for you to know some of your cubed roots. I think especially up to 5 or 6 is a pretty reasonable expectation to know your cubes. One last step, and the last step is to remove this 2, and we remove this 2 by simply dividing. And so we divide by 2 and divide by 2. And so x, if you want to write it as a fraction, is 125 over 2. If you'd rather not write as a fraction, it can be 62.5. Whatever you like for your answer is reasonable. Okay, let's come to another problem. In this one, we'll have a couple more layers involved. So we'll go x plus 2 cubed plus 3, or x plus 2 squared plus 3 squared plus 4 equals 20. Again, we always have to look outside in. We have to work from the outside of our problem to the inside. Now, as I look at this, I hope you're starting to get better at seeing the outside and the inside part. And what I see is this x plus 2 is the most inside, and then the squared. The x plus 3 is the next inside part, and then the squared, and finally the 4 is the last part. So the first thing we're going to knock off is we're going to get rid of this 4, and we're going to undo from that. One thing I'm trying to get used to as we do these problems is giving you things that are kind of complicated and having a lot going on, both in the exercises and in the homework. And the reason is because I want you to see that things that may look scary and look intimidating don't have to be if you just use the things that we know, use the things that we understand, and just address them one at a time in a nice, simple, methodical answer. So don't try to answer the whole problem at once. Just try to tackle the part that you know. I think this is a reasonable life lesson as well. I think that even outside of the mathematics courses, sometimes we get intimidated looking at a whole project at once. Instead, if we just look at it in pieces and say, what can I do today? What can I get done today? Then you can be productive and make progress. So let's go about solving this problem. First thing we need to do is subtract 4 to get rid of this 4. And that gives us x plus 2 squared plus 3 squared equals 16. And now what we have to do is, it looks like the next outermost piece is this squared term, so it looks like that's the term that we're going to need to get rid of next. We undo squares with square roots, and this gives us on the right, we get x plus 2 squared plus 3 is equal to 4. Let me make a quick point that I probably should have made earlier, and that is, you'll remember whenever we take squares, some of you will recall whenever we take squares that we actually always get two answers. We always get a plus or a minus. And the correct answer, or the complete answer for this problem, is plus or minus 4. In a very similar way, when we solved this problem earlier, our complete answer should have been plus or minus 2/5. And so we should have not had one answer, but two. If you remember that, that's fine. That's excellent. You're a step ahead of the game. But for today, I don't want to get too worried about when solutions have more than one solution and when they don't. I just want to focus on this process of working inside out. So I'm not going to include plus or minuses today. In just a couple periods, we're going to talk about when problems have multiple solutions. We'll come back to that. We'll add in the plus and minuses, and we'll try to make these problems a little bit more full and more complete. Okay. So we've taken the square root of 16. We'll just call it 4, even though there's also a negative 4. We'll just ignore that for now. Now, let's come in. Let's subtract the 3. So notice that this 3 is on the outside now. Again, hopefully you're starting to get used to when things are on the inside and when they're on the outside. So let's subtract 3 from this problem, and we'll get x plus 2 squared is now going to equal just 1. Now the next thing to do is to get rid of this square, and so we square root both sides, and we get x plus 2 is equal to the square root of 1. The square root of 1 is just 1. And so now finally we subtract our 2, and x is equal to negative 1. Just as we did last time, you could check this answer if you wanted. If you wanted to check the answer, we would take this negative 1, put it right here for x, do all the computations that this commands us to do, and see if our answer is 20. If our answer is 20, we did the problem correct. If our answer is not 20, then we made a mistake somewhere. Okay, let's end today by giving you a couple of problems. I'll give you these problems right here. I forgot to label them, so let's call this problem A and this problem B. And here are two problems to work with, problem A and problem B. As we always do, take just a minute, try the problems on your own, pause your device right now, attempt both of them, and come back and see how successful you were. Okay, and we're back. You've unpaused. You've either unpaused or you've decided to skip trying them on your own. If you just did the latter, I would first hope to shame you a little bit, but second to tell you that you're only cheating yourself because you're making it harder to learn material because you're not giving it your own attempt. But what are the answers I got for these problems? I got the answer x equals 81 and x equals 5/2 for my two solutions. If you didn't get those two solutions, go back and look at your work. And if you'd like more, we should have links to solutions of these to these problems over here on the right. So look for your solutions. Click on these if you need to, and I'll see you next time.